Well, hi everybody. I got a new video for you here on trigonometry, sum and difference formulas. And let's write them all down. You have the sine of u plus v. U is an angle, v is an angle. You take the sine of u times the cosine of v plus the sine of v cosine u. We might take some time to show that. I'm going to rearrange that and write cosine u sine v, just to conform to what the order the book has. And then sine u cosine v for minus cosine u sine v. So you're taking the sine and cosine of each separate angle. On the sum, you're adding these amounts. On the difference, you're subtracting these amounts. Cosine of u plus v, cosine u, cosine v. Now this cosine u, cosine v minus sine u, sine v. And cosine of u minus v is cosine u, cosine v plus sine u, sine v. Just know that on cosine, the cosines go together and the sines go together, but you do kind of the opposite in the middle here. Now tangent is a ratio here, and it's the tangent of u plus tangent of v over 1 minus tangent of u times tangent of v. And tangent of u minus v is tangent of u minus tangent of v. So it's going to be minus up here. Down here with the 1, it's going to be plus. 1 plus tangent u tangent v. Alright, so we're going to use this, and there's different paths you can take here, but I'm going to use it to find the exact value of cosine of pi over 12. This means when exact value, we're probably going to be getting into our unit circles, and find the exact value of cosine of pi over 12. So let's well, 1 pi over 12. If I take 4 pi over 12 minus 3 pi over 12, I'll have 1 pi over 12. I just need two values. And the nice thing about this is the way these reduce. That's pi over 3 minus pi over 4. So if I let pi over 3 be my u and pi over 4 be my v, and I'm using the cosine, I'm going to use this identity that we have here, that formula. So we're going to take the cosine of pi over 3 minus pi over 4, which is the cosine of pi over 3 times the cosine of pi over 4 plus the sine of pi over 3 times the sine of pi over 4. Alright, let me get kind of a picture. Pi over 3 is right here, so the cosine is 1/2. Pi over 4, that's square root of 2 over 2. The sine of pi over 3, that's the square root of 3 over 2. And sine of pi over 4 is square root of 2 over 2. And so I've got the square root of 2 over 4 plus the square root of 6 over 4, and I'll just write that like so. This is the exact value. Anything else I do, I don't think would be simplifying it. And using the calculator would be approximating, would not be exact. All right, so that's with a radian problem. Now with a degree problem, sine of 75. Is there a value for 75 that you can think of with sum or difference? And there is one, I think 30 degrees plus 45 degrees. This is very similar to this one, but it's plus here, is equal to 75 degrees. So if I let this be my u and this be my v, then I'm going to find the sine of 30 degrees plus 45 degrees. That's the same as sine of 75. And sine with plus is sine of 30 cosine 45, these are degrees, plus cosine 30 sine 45 degrees. I guess we do that just to keep the angles in the same order. So sine of 30, now we're over here now, sine of 30 is 1/2 cosine of 45 square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Sine of 45 is square root of 2 over 2. So that looks like square root of 2 over 4 plus square root of 6 over 4. Looks like we got the same thing. That the sine of 75 degrees is equal to the cosine of pi over 12. Alright, so I think we could probably use a cofunction that would go in line with a cofunction identity. Now, I'm looking at example 3 here. I actually may need to go back to my formula. Okay, tangent of 5 pi over 9 plus tangent of, this is plus, and this is minus, and we got the 5 pi over 9 and the pi over 9. So that looks to me plus minus. That looks like a tangent of 5 pi over 9 plus pi over 9, which is 6 pi over 9. 6 ninths is 2/3. So that's the tangent of 2 pi over 3. 2 pi over 3. Now whereabouts is that? This is pi over 2. Which is 3 pi over 6. That's 4 pi over 6. That's right here. Alright, tangent is sine over cosine. The cosine of this one is negative 1/2, and the sine is square root of 3 over 2. So I'm looking at square root of 3 over 2 over negative 1/2. These 2's are going to cancel out. The 2's that are in denominators and then top and bottom. So that's, I got the square root of 3 over negative 1, or the negative square root of 3. That's what this equals. Check it out. We could check it out on the calculator. That'd be fun. Alright, example 4. Last example here. Given that the sine of u equals negative 7/25 and cosine of u equals negative 4/5, u and v are said to be in quadrant 3, find the exact value of the cosecant. I don't have a cosecant of u plus v. What I do have is a alright, I got stopped there. I'm going to change this. I think I could do it either way, but I'm going to change this so that I have the sine of u and the cosine of v. Actually, no, that wouldn't have worked anyway. So this had to happen. I miswrote the problem and had u there instead of v. So just get that changed if you haven't already. Now, because sine squared plus cosine squared would not equal 1 if this were the same angle. So we're okay. And that's what I want to do here. We're in the third quadrant. Quadrant 3, sine and cosine are both negative. I'm going to use the sine squared plus cosine squared. You can draw a triangle if you want. But I'm going to go sine squared u plus cosine squared u is equal to 1. And then that's negative 7/25 squared plus cosine squared u is equal to 1. What is that? That's 49 over 225 plus cosine squared u. I'm trying to figure out what cosine of u is because I need that for my identity. Equals 1. If I subtract, and 225 minus 49 is, okay, let me see here. Oh, jeez, that's 625. Sorry. 15 squared is 225. All right, so let's take, I had 400 of that, I'll get the right thing. That's 576. So 625 minus 49, so the cosine squared u is 576 over 625. If you're not following what I did, I just thought of this as 625 over 625, subtracted 49 from 625. And then the square root of 576 over 625 is equal to 0.96, and that happens to be 24 over 25. And if you don't believe me, I'll change it to a fraction for you. See, 24 25ths. So cosine of u equals plus or minus 24 25ths, but since it's, we're going to choose the negative, cosine of u is negative 24 25ths. And like I said, you could have done the triangle, just made a right triangle. It might have even been a little easier. Maybe let's try that with v. We said we're in the third quadrant. The y is negative 4. Well, I don't need to be too exacting here. Y over x. So negative 4 and okay. So the cosine is negative 4. So we'll go 1, 2, 3, 4, 5. And then the sine, 1, 2, 3, 4. So, okay. I said I wasn't going to mark this up. So I'm going to just draw theta here and draw this, and then know that I'm going opposite over adjacent. So I'm doing the y, which is 4, adjacent's 5. So negative 4 and negative 5. And it's sine, it's not, okay. All right. I'm gonna do a reboot here. Okay. Starting all over here again. Cosine is negative 4/5. We're in the third quadrant. So cosine is adjacent over hypotenuse. So here's negative 4, here's 5 here. All right, now I feel a little better about this. And if you would do a Pythagorean theorem, you'd see this is negative 3 down there. So the sine of v is negative 3/5. You might be better off just doing this if you just get as turned around as I just did there. All right. So we know all the things we need to know, and we're finding the cosecant. Ooh, but I'm going to have to do sine first, and then I'll switch her around. So the sine of u plus v, let's check out that identity again. Sine is sine cosine, sine u cosine v plus cosine u sine v. Sine u, I'll write it out. Sine u cosine v plus cosine u sine v. All right, sine of u. I know what that is. That's negative 7/25. Cosine v is negative 4/5. Cosine u is negative 24/25. And sine v is negative 3/5. So I'm looking at 28 over 125 plus 72 over 125, which looks to me like 100. That's not a bad number here, over 125, 28 and 72, which if I divide by 25, I've got 4/5. Okay, so the cosecant of u plus v would equal 5/4. All right, there we go.